Oh, and there we go. We are at half past the hour. We're now live. Hello and welcome to Slooh, where students from around the world control mountaintop, actually volcano top telescopes as they learn about astronomy in space in our standards aligned curriculum and Quest learning activities. We'll talk about some of those a little bit more later. But today we are going to enjoy one of the best celestial events of the year. I'm going to ask some of the community. I know we've got some students in watching on the event page on Slooh. We've got some Slooh members in the webinar as well. We are going to be watching together the Geminid meteor shower. We're going to talk about this a lot later, but this is one of the best showers for a whole number of reasons. And actually, I think one of the most fascinating to learn about as well. So I'm Paul Cox, and together with our expert educators tonight, we can see them here, Keith and Milton, we're going to be explaining everything there is to know. I hope you're ready for this. Everything there is to know about meteors as we watch for Geminids whizzing across the live streams that are going to be joining us very shortly directly from the Canary Islands. And the Canary Islands is home to just one of Slooh's observatories. It's actually where Slooh's largest telescope is installed at the Institute of Astrophysics of the Canary Islands. Do excuse me if I'm a little bit bleary-eyed because I've only just jumped off an airplane on my way back from the observatory. Why I didn't stay there to be able to see the meteors with my own eyes, I don't know. But anyway, what are we going to learn about tonight? So to help us with this, I'm going to introduce Keith. Keith is an educator and expert community member. And Keith, what are we actually watching tonight? So this is a meteor shower. What is a meteor shower, first of all?
Okay, well, first of all, thank you for having me, Paul. It's a pleasure to be here. A meteor shower. So there is debris that floats around out in space. Some of it is pieces of comet, asteroid, space dust, stuff out there. And the Earth, as it makes its way around the sun, will pass through these debris fields. And when these objects, anywhere from the size of a grain of sand to a small pebble or a piece of rock, um, will get captured by the Earth's gravitational pull and it will burn up in the atmosphere. So the objects, the pieces of debris floating out in space, we call a meteoroid. The object, the burning up thing in the sky that we see, we call a meteor. That's what a meteor is. And if the object strikes the Earth and you can pick it up, that's the meteorite. A meteor shower is when we pass through a heavy concentration of this debris, and we see so many per hour. With the Geminids, we can hope to see in a dark sky environment, maybe 100 an hour. So
Yeah, we'll
uh,
talk about some of the rates a little bit later because
okay.
hopefully we'll a lot of people watching, a lot of students in the USA watching. Hopefully, you're going to have clear skies tonight. So we're going to give you some tips on how you can watch the meteor shower from your own backyard tonight. But it's interesting that you were talking about meteorites there because meteorites don't often come from meteor showers, but actually the Geminids, it's one of the peculiar things about the Geminids that some of those meteoroids don't fully burn up in the atmosphere. Some of them do reach the ground, and that's because the meteoroids from the Geminid meteor stream, the stream of debris that Keith is talking about, are a lot denser than most debris streams that are left by comets. Now, Keith, there's the big clue. What makes the Geminids so different? Is that stream of material left by a comet, or is it another
This,
type of object?
this is the most exciting part about it. Most of the meteor showers that we have are pieces of comet that are left behind, and they're smaller pieces of dust, so they do burn up in the atmosphere. There's nothing left behind. But the thing that makes the Geminid special is that the parent object is not a comet at all. Comet is a dirty snowball. It's an asteroid. It's asteroid. Yeah, there it is, asteroid Phaethon. And it has a very bizarre orbit. There are a lot of irregularities with this object. In fact, Phaethon has become my current favorite object. It lives out in the asteroid belt, the main asteroid belt, which is that a region of asteroids and other debris between Mars and Jupiter in orbit around the sun, but it doesn't follow in the plane of the ecliptic. So most of the
So just
planets,
Keith, just explain to students watching this what this
sure.
diagram is actually depicting to start off with.
Okay. So we see the sun in the center and we see the interior planets. So Mercury is closest. We see Venus. The blue line is the Earth, and the red is Mars.
Okay.
So Phaethon lives out in that region between Mars and Jupiter. We don't see Jupiter in the diagram because, according to scale,
No,
it's
far
very
away.
far out. Yeah, it's
Yeah.
way out there, so you're not going to see it. When we think of comets, comets live, they're trans-Neptunian objects. They're beyond Neptune. They're out past Pluto. They're out in a region that we call the Kuiper Belt at the very edge of the solar system. That's where we see comets usually from. Phaethon is not out there. It's in this asteroid belt. And what's unusual about it is that it actually visits the Earth, at least passes through the Earth's orbit, and orbits around the sun. So if we just take a look here at the purple dot, that's the asteroid. It has this strange elliptical orbit like a comet. And in fact, it's more comet-like in its behavior than it is like an asteroid. But it's not cometary material. This has a rocky,
Mm.
possibly metallic, or a mix of the two, core, as many asteroids do. So it's not a snowy, dirty snowball. It's not ice and dirt and rock. It's pretty much just rock. And it behaves like a comet, loops around the sun. We'll watch it here, goes way out to where it lives between Mars and Jupiter. And then we'll pick up speed and be slingshotted around the sun, just like a comet, but
Yeah.
goes back home to the asteroid belt. Has a very short orbital period, about 19 months. So
19 months. So it's coming around, thick and fast. We'll talk about, there's a really interesting aspect of the Geminids, which is linked to that a little bit later on. But I just wanted to mention there's, for any teachers out there, all students, we've got a Quest learning activity, which is about learning Kepler's laws of planetary motion, which is kind of absolute. This is a classic, example of that with, Phaethon speeding up as it whips around the sun. So there it is, Keith. We've got Phaethon actually crossing through the orbital plane of the Earth. And so this is why we tend to see meteor showers only on 1 or 2 nights, or we see a peak over 1 or 2 nights. We can see them over longer periods of time. But that's because we're passing through one of those streams of material that Phaethon actually traveled through. Is that right?
yeah, that's exactly it. So unlike a comet, where, as it gets closer to the sun, that ice starts to melt and starts to release debris and creates a tail and all of that, and that becomes the material that we see in a meteor shower. With Phaethon, um, it's a different situation. The current belief is that there is gas at the core, and as it approaches the sun, it dissipates and casts off some of its outer layer in these large chunks. So it's not dust; it's larger pieces of
Yeah.
debris. And when it gets close to the sun and it leaves this debris trail that's very dense, and we pass through it, that's what we have. We have 100 or more meteors per hour
Yeah.
that we hopefully will get.
So
That's it.
Keith, Phaethon, we can see the word up there on the screen while we wait for our live feeds. Don't forget, we got these live feeds coming in from our partners in the Canary Islands. They've been very, very successful in the past. So cross fingers, those are going to come up live. And as soon as they do, we need to fix our eyes on there, because I guarantee you one thing with meteor showers: the moment you look away, you hear everybody else screaming, "Hey, wow, did you see that one?" And you've missed it. You've missed it. I've missed so many like that. But anyway, look, we can see the name there. Keith, why is it called Phaethon? It's a pretty weird name.
Yeah, Phaethon. So again, a character from Greek mythology. When we see objects named, there's usually a theme. And here we have this theme of Phaethon and the sun, because it has this close approach to the sun, which asteroids normally do not do. Phaethon was the son of Helios and Clymene. Helios is the god of the sun, and he went to verify his parentage. And he goes, "Yes, you are my son." And Phaethon, like a lot of teenagers, if we can think of him as being one, uh, wanted to drive this chariot. And like many children, he was not a good driver. He was admonished several times by
Oh, hold
Helios,
on a
"Do
sec,
not
Keith.
drive
Hold on a
this."
sec.
Sorry.
While
Okay.
you are going to tell us, let's introduce this. This is our first live feed coming up. I can't recognize any constellations there. As soon as anybody can, then do. But this is a live video stream from our partners at skylive.tv. It's actually run by a group of people at the Institute of Astrophysics of the Canary Islands. So thank you very much for providing the feed tonight. We can see we've got a beautiful, clear sky tonight. Now then, before Keith finishes off the story, I want to tell you what to keep an eye open for. We can see little flashes of light here and there. There's just hot pixels in the camera, just flashing on and off, and some of the stars kind of going on and off. Not on and off, but it's just because of the live feed. What we're waiting to see is a very fast line whizzing through against the background stars. So keep your eyes peeled. And this is where it gets difficult, because I get very distracted now. I'm going to be looking at the live feed all the time, not concentrating on what you're saying, Keith, but please carry on going.
Okay. Well, yeah. So Phaethon, the bad driver, uh, could not control this chariot. Sometimes he was too close to the sun, too close to the earth, which caused parts of the earth to dry up and get baked. Sometimes he was too far away from the sun, and parts of the earth froze. There were complaints about this, so Ilios responded by striking him with a thunderbolt, and Phaethon fell into the river Eridanus. So why does the name Phaethon fit here? Well, it's very close to the sun. So he's driving that chariot across the sky, very close to the sun, then going very far away in a very erratic orbit. So he's obviously a bad
Did anybody
driver.
see that?
So that's part of it.
Did anybody see that down at the bottom?
I don't
You know what? I looked away for 1 second. 1 second.
Oh no.
I told you. I warn you all students out there, whether you're watching these live feeds or whether you're in your backyard tonight, just keep looking up. We are going to tell you how best to watch this from your own backyard. But sorry, Keith, I interrupted you. Tonight, meteor showers are those kind of live events. They can be a bit disjointed because we have to react to exactly what's going on in the live feed. So, Keith, I apologize. I'm a dreadful host. I interrupted you once again.
Not at all. No, that's it. Phaethon. That's how he got the name. He has this relationship with the sun, and that's it. It's very similar to the bad student driver that Phaethon of Greek mythology.
And that's what we were seeing in that orbital diagram. We were seeing it actually. Was it going within the orbit of Mercury? Was it getting that close to
Very
the sun?
close. It's within the orbit of Mercury, so you have this very close relationship with the sun. Again, it's more comet-like than it is asteroid-like, but it doesn't live where comets live. It lives out in the asteroid belt, and for whatever reason, just like its namesake, it has this desire to get sucked in into this path with the sun like a comet does, but for whatever reason, while other ones don't. You know why? I don't know. But that's what happens.
What we see, you described comets earlier as kind of dirty snowballs, these kind of loose amalgams of ice and dust and all sorts of volatile substances, kind of loosely clumped together. We see so many comets not survive a close passage with the sun. They break up, they disintegrate. Sometimes they fall out of view as they go behind the sun, and we don't even see them re-emerge because they've been destroyed. Now, Phaethon, we know, is an asteroid. It's a lot denser than a comet, but going so close to the sun so frequently, every 19 months, you were saying, there's a possibility that it could also be ripped apart by the enormous gravity of our sun when it gets that close. So it's going to be fascinating to kind of watch this, because this is actually quite a recent discovery as far as asteroids are concerned, isn't it, Keith?
Yeah, this is not one that was known in antiquity, although some were. The 1983 is usually given as the discovery of Phaethon. But the event itself was observed in the 1860s. So it's relatively new, even for, in terms of observation. We didn't know what the object was, but even in terms of seeing meteors radiating from this area of the Gemini, of Gemini, Castor, and Pollux is even relatively new itself. So yeah, it could get ripped apart. That's definitely something we have to think about. The wear and tear on this, it could also get sucked in by the sun. We saw a sun grazer comet. Somebody posted on Discord, just vanished into the sun. It just got sucked right in. No more comet.
No more comet. Poof. And it's gone. Hopefully this one won't disappear quite that quickly. So we'll have a few more. And actually, Keith, I want to talk about the rates, the number of meteors people can expect to see in the Geminids. But before we talk about that, that was definitely one. Did you see it down in the left-hand side of our feed? Great. Okay, there is our first absolutely confirmed Geminid meteor whizzing through quite a short. And there's another one. Look at that. And one of the things we're going to notice tonight is whichever view that we're looking at, we'll know that it's a Geminid if it appears to be emanating from the same place as all of the others. If we see a streak, let's say, coming from the right-hand side and streaking up across the image up to the left, that's going to be a sporadic meteor. That's just a normal meteor that we see. But we're going to talk about why we see all of the Geminids. They appear to emanate from the same place, which is called the radiant. But Keith, I wanted to ask you about another peculiarity of the Geminids. So many meteor showers are kind of getting worse and worse. In other words, the number of meteors that we see in them are getting lower. But the Geminids, it's the opposite, isn't it? And has that got to do with how often, how frequently Phaethon is orbiting and crossing Earth's path?
Sure, absolutely. When we think of a comet that visits every 100 years, every few hundred years, every 1,000 years, or maybe this is the only time we've seen a comet. Comets can be periodic. They return and come back and go back and come back, or non-periodic, once in a lifetime type of thing. Phaethon keeps coming back again and again and again, and whatever it is that causes it to shed off some of its outer layers is continuing to do that each time it returns. So it's replenishing whatever debris and whatever material is out there that we are passing through. Whereas if it's a comet, that debris eventually is going to...
Oh, is that another
There
one?
we go.
At the top?
Yeah.
That's number 3, isn't it? Okay, somebody hopefully is keeping count on this. So hopefully if you're a student in the webinar, be keeping a count in chat or anything like that. If you're watching live, and hopefully you're watching with friends or family as well, keep a count. Some people make a wish. I actually make a wish.
Okay.
We'll maybe talk about that at the end of the show, because we are going to talk about how meteor showers are seen in different cultures and things like that a little bit later with Milton. So, Keith, we were saying that the Geminids, unlike some of the other meteor showers, are actually getting richer and richer in the number of meteors that we can expect to see. The other thing I love, by the way, about the Geminids is so many meteor showers are best in the pre-dawn hours. So I always recommend to people, don't stay up late, get up early. But the Geminids isn't like that, and that's why it's one of the great there was Miguel, who's at the Institute of Astrophysics. He's giving a demonstration there to people. So let's keep on this feed for the moment. So the best time actually to watch the Geminids is in the evening, kind of in the hours before midnight, and that's what it is in the Canary Islands at the moment. We started at 10:30 p.m. local time, and that's a really good time to go out. You can go out as soon as it's dark, but Keith, we often see quotes, and I do find this a little bit unfortunate, because sometimes in the media and on TV you see these the meteor rates quoted, and they're so... there's a lovely other one coming in straight down as well. They're fairly short, these ones. They're fairly short, so that's pretty good. Wasn't the cursor the arrow shaped thing that we just saw there? That was a good one. So we often see these what I class as exaggerated rates, because the rates so often cited in the newspaper and elsewhere and on TV are the rates that you might see under absolutely ideal conditions, when this radiant, this place where the meteors appear to emanate for, is directly overhead, where there is zero haze. You've got a totally dark sky with no moonlight. Thankfully, we've got no moonlight tonight. With no light pollution. Thankfully, we've got no light pollution tonight, because the Canary Islands, where our telescopes are based, that students use all the time, is protected by their light laws. Would you believe? They really understand and value their dark skies in the Canary Islands. And for goodness sake, the largest optical telescope in the world is based there. So keep watching for those. So Keith, tell us a little bit more about the rate of meteors that we see quoted versus what people can expect to see. Now, we see this number quoted 100, and we normally see ZHR along with that number. Can you shed light on what we're reading there?
Yeah, these exaggerated rates, I think, is kind of the operative term. First of all, a number of factors are going to affect what it is that you're going to see. Is the moon there? Full moon during a meteor shower, forget it. All those faint meteors you're not going to see. The moon just has a tendency to wash out everything but the brightest stars, so you're not going to see meteor. Light pollution, again, has a big part to play too. Where are you? If you're out in a very, very dark sky environment, you may see more once your eyes are dark adapted, which is another thing. If you're going to go in and watch television, then go out and sit outside for 5 minutes. That's not going to work either. I don't care how dark it is. You have to be out for like half an hour and let yourself adapt. And also where you're looking. You have to, first of all, know where the radiant is, but you don't want to stare at the radiant. You just kind of want to get in that zone where you're just taking in, soaking up as much of the sky as you can, so you can allow different parts of your eye and your peripheral vision to pick up what it is that you're going to see. How high the radiant is in the sky is also going to have a part to play. You don't want to have, the radiant near the horizon where you're going to miss the entire bottom portion of potential things that you might see. The reason the Geminids are so good is because Gemini is high in the sky at 10 o'clock earlier in the night. So 10 o'clock, midnight, 2 in the morning, you can be done, because Gemini is very, very high in the sky. Castor and Pollux are the two stars that we identify Gemini by. And about midnight or 1 in the morning, they're directly overhead, which is actually kind of difficult unless you have a lawn chair or something to look at, because you'll be doing a lot of neck straining. But that's, viewer experience may vary depending on really all of those factors.
Exactly. And I don't think ever seen more than probably 1 meteor every 5 minutes, and that is just over a fairly short period of time. So when we see this quoted for the Gemini is 100 meteors per hour, you won't see that. So get your expectations together, because it's still a spectacular event to actually watch. And I think that brings us on. We're going to talk a little bit more about the Geminids in particular, Keith. But you mentioned there about where to look. So we can imagine, there's a lovely feed that's coming from the observatory in Tenerife. So, and what can we see?
Orion.
Yep. So we can see. So we've got maybe Gretchen, if you can spot those, maybe if you can point out the belt of Orion, which may orientate people. No, up. So that's it. Those 3. So we've got the belt of Orion there.
Right here. Sorry about that.
Yep. So the first thing that Gretchen then just pointed to was Orion's belt, and that is home actually to one of my favorite objects to capture in the Slooh telescopes, the Great Orion Nebula. But all in that same little area, we've got the Orion Nebula, we've got the Flame Nebula, we've got a dark nebula called the Horsehead Nebula, which is absolutely spectacular in the half-meter telescope when students capture that. But it's an incredibly rich area of the sky. Now, when you go out from about, as soon as darkness falls, actually, Keith, Orion is visible at the moment, isn't it? So that's a fairly easy thing to spot in the night sky, which is a great kind of segue into maybe suggesting how people can watch this. Where should they look? Because you were talking about the radiant. So the radiant is the spot in the sky, which happens to be in the constellation of Gemini. And all of the meteors appear to radiate from that. That's a laser, by the way. So I don't know if we can flick to the other feed. That's it. So, oh no, Miguel's there. He's still explaining. So he is still explaining to their on-site visitors what to look at there, just in the same way that we're trying to do at the moment as well. Right, where was I? So we've got all of the meteors appearing to emanate from the same spot. Now, if you look at the radiant, so if you look at the constellation of Gemini, with those two bright stars marking it, you'll be able to spot them quite easily. The meteors that are coming from there are going to be very, very short. The trails are going to be very, very short. So never look at that. Keith, I'm going to ask you, and then I'm going to ask Milton, what your favorite meteor watching method is, and then I'll share what mine is. Keith, first of all.
Okay. Well, it depends on really where the radiant is. It depends on how high it is on the sky. I'm not a big neck stretcher or craner. I don't like waking up the next day not being able to move. So that's a big determining thing. Lawn chair is ideal if you have, a lawn chair where you can adjust the back and just kind of, like for the Perseids, that's right over the edge of our deck, our yard. So I just tilt back the lawn chair, and Perseus is right there, and I just kind of soak it all in. That's I like.
But for the Geminids, what would you be doing tonight for the Geminids if you had clear skies?
The same thing. I leave that lawn chair out all winter, so
Yeah.
I would just move it in a slightly different direction to accommodate where it is in the sky.
Okay.
And that would be it. It hasn't been
Okay.
cold, so I really have no excuse to not be out. And it's not just tonight. They will talk about the peak nights, but you can see for about a month, the debris field. So, a couple of days before, a couple of days after, you're fine. So I can still go out tomorrow. And that's it,
Milton, how
Buckling
about
up
you?
if it's cold.
What's your favorite meteor watching strategy if you're watching it from your own backyard?
Just like Keith said, I would probably just find the best lawn chair and then enjoy the view. Now, I always try to see that against or very not too high on the horizon, let's say. So they last longer. For some reason, I think they last longer. But that would be my favorite.
Okay, so I'm exactly the same as both of you. Comfort is everything as far as meteor showers is concerned. The summer meteor showers, they're great because it's still nice and warm, but you have to stay out late because the night's really short. But the Gemini's meteor shower, you can go out as soon as darkness falls and you can start seeing some meteors. Stay up until midnight, maybe, as Keith has said, and do exactly what both Keith and Milton have suggested. Get a lawn chair, something that you can lie down on, and just get comfortable. And then what I do is I don't focus. It's very easy when you're trying to watch a meteor shower to get tunnel vision, to kind of focus in on one star or one group of stars. Try and just relax your eyes and be aware of your peripheral vision as well. And you'll be amazed if you are lying down, suddenly, if you've got a good horizon, you're going to be seeing a lot more of the sky rather than if you're standing up, half of it's hidden behind your head. Lie back in comfort, see as much sky as you can, and just be aware. I think it just takes, it's difficult to explain, but just be aware of your peripheral vision, because you'll be really, really surprised that as soon as you see even the start of a meteor over here, how quickly your attention and vision can go to it. So just kind of see as much sky as you can. Now, I talked there, Keith, about the speed and being able to react, to turn around and focus on a meteor as soon as it starts. Different meteor showers, the meteors at different speeds, aren't they, as they travel? Oh, there was a nice little one down there. Did you see it at the bottom of this? I don't know how I'm doing this. Come on, how come I'm the first one to see these? Come on, yes. Yeah. So we've just seen another one. Lawn chair, somebody else is saying in chat as well. Keith, meteors, that looked pretty fast to me, the way that whizzed through the sky. But different meteor showers, the meteors travel through the sky at different speeds. So, oh, that's the best one of the night. Thank you very much. Yes, that's definitely worth a wish, that one. So yeah, I should be out. I'm always altruistic with my first wishes, and then it gets more and more selfish as the evening goes on. Keith, speed of meteors, because that actually looked fairly slow. Is that typical of a Geminid meteor?
That's what we want to see. We want to see those nice, slow, long, sort of like low-lying fruit, even though they're up higher in the sky. It all depends on how that parent object leaves its trail of debris, and that depends on how its orbit is around the sun and where it crosses the orbital path of the Earth. So this comes in kind of like in a sideways type of arrangement. So they're not steep like some of the summer meteor showers. You get them, they're very steep. They come at you quickly because that's how debris was left. And as we pass through it, that's what happens. Here you get that nice horizontal pattern of the streak across the sky, and slower because the pieces of rock are larger. It takes a little bit longer for them to burn up. And it's just the nature of the debris and where it is and how it is. Each shower is different, based on the time of year, seasonality, and that kind of thing. And that path of debris, how it's left, will have a part to play in how they appear in the sky.
And that was absolutely classic Meteor, wasn't it? We saw the beginning of the trail just as it's entering the atmosphere. So don't forget, Keith told us at the beginning, that little speck of debris is called a meteoroid when it's actually traveling through space. When it enters the atmosphere and starts to burn up and vaporize like that, it's called a meteor. If it were big enough for a little fraction, a little particle of it to actually hit the ground, the thing that actually lands on the ground is called a meteorite. But what we saw there was the beginning of it burning up, and then it heats up until you see it in its disintegration phase where it got very, very bright, and then it just tails off again. So that's an absolutely classic meteor, and that's what you should be looking for tonight. Some of the things that people mistake for meteors, if you see a constant white light traveling across the sky fairly slowly, these can appear quite slow. Some of them, when they're a little bit closer to Earth, can appear to move a little bit faster. Most of those are satellites, and you can normally tell a satellite because of its fairly steady motion across the sky, and there's no blinking. It's just a constant light. It normally gets brighter and then darker, but over a long period of time. If you're lucky enough, you can see the International Space Station passing over, and that's really quite bright. If you're unlucky, you might see some of the Starlink satellites, which are actually the cause of a little bit of consternation to astronomers. Now, if you see anything that's blinking in the sky, flashing on and off, but traveling across the sky, that's more than likely an aircraft of some kind. If you see anything with little green men sticking their noses out of a window and waving at you, well, it's you've probably eaten something bad. But anyway, right. The Keith, what else have we got to talk about with the Geminids in particular? We've said that it's getting richer over the time. We've said that they kind of hit the Earth's atmosphere sideways, not head on like the Leonids and Perseids. And we've said the best time to watch it is kind of early evening, or from dark. I think from dusk to midnight, I think would be our recommendation on that, wouldn't it?
Yeah, and there's, Milton had mentioned that some of these he sees when they're lower on the horizon. When you have that type of layout, that type of situation, you have the chance to catch these Earth grazers, which are very low-lying meteors that, again, will kind of run parallel to the horizon. And then we get into the atmospheric disturbance, and you get some color. You get this bright orangish, yellowish color, and they're very beautiful. And especially when you get into a fireball, which is a meteor that just lasts longer and longer and reaches a greater magnitude.
Yeah.
Really, really exciting when you can see those. I don't know if we'll see some fireballs tonight, but it would be great if we did.
Yeah, we don't see that many fireballs, do we, with the
No.
Geminids? But there's always a chance. I mean, that one that we just saw was not that far off. But I did see a fascinating photo last night. I meant to try and grab it so that we could share it on here. I'll share it maybe on the Discord server, Slooh's Discord server, and also on the student forums as well. But it was a meteor, a Geminid meteor that actually waggled. So somebody took a photo of this actually from the Institute of Astrophysics at the Canary Islands, and it was coming vertically down, and you could see the whole line was waving. And just below it, you could see this red fiery storm on the horizon. That's what it looked like. And what it was the volcano eruption in La Palma. And what the scientists at the Institute of Astrophysics at the Canary Islands believe is the meteor was coming through the high level atmosphere, because that's where the meteor's burning up. There's a lovely one going across there. That was a good one. Milton caught it as well. Well done, Milton. The heat from the volcano was going high up into the atmosphere, and they believed that the meteor, as it was passing through, what we were seeing was the extreme turbulence in the upper atmosphere as the meteor came through. It was an absolutely extraordinary photo. We will share that in the Slooh community. So Keith, we are going to welcome you back a little bit later on, and we'll dig in a little bit more about the Geminids and maybe Phaethon and the asteroid belt and things like that. But for now, I would like to welcome Milton. Now, Milton, Mayan Law, you are an educator, a Slooh community expert. You've written a terrific, is it one or two culture quest learning activities now?
Now two.
Two.
Soon I'm submitting another one.
Excellent. That's what we like to hear. Now, most of your quests and a lot of your interests are archaeoastronomy, especially when it comes to the law of Mesoamerica. Oh, was that another meteor? Did we see that?
Was another.
Did you see you did? I was looking down at my notes, and it was just there. I just saw it out of the corner of my eye. There you go. That's exactly the same as observing outside. You can be concentrating on one thing, and then suddenly your eye gets taken elsewhere. How did the Maya figure out what was going on in the skies? They had their calendar, I think, which you've talked about before. Is that right?
Oh, that's right. I would preface this answer by saying each of these meteor showers for us is like a star party, right? That's what we like to do. We rejoice at the view. For them, unfortunately, it was not so nice. Each of these meteor showers for them was as if the sky was falling to earth, and so for them it was a bad omen when these things happen. Actually, it was a mixture of things, right? Many of them believe that it was the sky falling to earth. They did not have a really good view of the Geminids, I would say, because of their position on the planet. They are more close to the tropics, and so their point of view is not the best one for that. But they did observe other meteor showers, basically from the result of the comet, Halley's comet, for example, that has its showers around the constellation of Aquarius, the Aquarids, as we would call them. What calls the attention of people is that there is no record of any meteor showers, despite the fact that they were great observers of the sky. They charted the movements of Venus, they charted the movements of all the planets, the sun, the moon. They had, years and years of observation that led them to form this calendar that you talked about a little earlier.
But none of the meteor showers that they must have witnessed.
They must have seen so many, but yeah, none of them. Now, let's confess that what we are doing with the material we are studying is trying to solve a jigsaw puzzle with more than half of the pieces missing. What we have is only the remnants of that culture in codices that are now mostly in Europe. The most famous of those is the Dresden in Germany. And those are pages and pages of numbers and predictions of movements of the planets, etc. And that is puzzling for us not to see any record of any meteor shower. But something else happened along the way. We started studying what the hieroglyphics said, and the hieroglyphics are a long tale of ascension to the throne and wars here, wars there. But when they compared those events to the meteor showers that they might have seen, and there goes another. They pair them almost to the day exactly, right?
Okay.
So, just for example, 4 days after the meteor shower in the year 531, the ruler Khan I, that's his name, ascended to the power in one of these cities in Caracol, in what is known now as Belize. So those kind of historic events recorded on these codices lead us to believe that it was those meteor showers they expected. They could even predict the meteor showers that they were going to see in order to prepare ceremonies of ascension to the power or starting a war with any other enemy, thinking that the gods would favor them in those enterprises.
Okay. So you were talking about, and it's, I've never really even thought about a meteor shower in these terms. To me, it's just an absolutely beautiful spectacle to watch. But as an ancient, without our understanding of what these things are, it must have looked like literally the stars were falling to the ground and the whole heavens were disintegrating over their heads. So you can understand why they saw these showers as bad omens. Now, I know that in many cultures around the world, and we've talked about this, on a lot of star parties over the years, that a lot of cultures saw comets as I think that the phrase that's normally used is harbingers of doom. I think Attila the Hun may have been the one exception, and he saw comets as good. And he used to, when there was a comet, he used to go, hell for leather and, start a new war somewhere. Oh, there's another one whizzing across, just as we were talking about that. So how were comets seen by the ancients in South America?
In Mesoamerica and South America, comets were seen as, the gods trying to tell us something.
Okay,
in South
but
America, for example,
not necessarily something bad.
no, trying to communicate with us, but the South Americans, for example, believe they were arrows that the gods were sending down. And because of what I told you about the Halley's Comet that left all this debris, for the Mesoamericans and the Maya in concrete, they were like falling hairs, they said, falling hairs or falling stars that were trying to say that something important was going to happen. So they paid a lot of attention to anything happening in the sky.
One of the peculiarities, I guess, as well with comets is they are all so different. We can see some that are looking very small and smudgy, which wouldn't even cover as Orion belt. Others we see arching across maybe half of the sky, so they would, and some appearing with two tails, one appearing with only one, some appearing with color, some not, some appearing in the evening, twilight, some the dawn. So they must have been quite difficult objects, I would think, for them to interpret, which maybe is coming across in your explanation there, that yes, it was some kind of message, but maybe a bit of a mixed message because they were all so different.
Absolutely. I believe that if we were listening to one of those, priests, let's say, they would probably try to make the very best of them. And we all know that, for example, these are physics in action, right? We
Yeah.
know that some of these elements are just gas. Some elements are, maybe the comet even breaking in two or three pieces or so on. But for them, they were probably trying to figure out what each of those colors and each of those shapes
Yeah.
would say. I can only imagine observing Halley's Comet every 76 years, let's say, for them, trying to find like a pattern for them, and all of a sudden, crossing the path of its debris, trying to say that this was the right time to attack or this was the right time to
Yeah.
take over the power. It's only natural to think that way.
And so much of their observations was about prophesizing. And we've talked about this before, Milton. You know, back then I lived just down the road from Stonehenge in the southwest of the UK. I always imagine when you tell us about your stories, I imagined these priests or whatever they were, a bit like the druids here, the power that was within them in these forecasts, and especially true, I think, when we've discussed eclipses before, when the moon has gone blood red, but they foretold it. They said next week. Did they have weeks? Who knows? Maybe tonight or tomorrow night, however they describe those terms. But they were able to forecast that, bang, yes, the moon goes red or the sky goes dark when the sun turns black. The power, the immense power that would have given them in their community must have been enormous.
Well, back then and today, knowledge is power. So
Yeah.
I can only imagine the long observation of the sky over not just years, but decades, and even longer periods of time, recording all those movements and figuring out that there is a pattern in each of these movements. That gave them a lot of power, and they were totally respected to the point that whatever they said was done. So uh, even then and today, knowing about this gives all of us, the power of um, of teaching what we know
Yeah.
and the respectable opinions that we may have.
And,
So
yeah, and your studies in archaeoastronomy is also trying to understand what they did, what they knew, what they didn't know. Plus, it's going back in time to understand what phenomena they could have been seeing. Now, our understanding of that, increases dramatically. But if we've got any students tonight who would be interested in this field of archaeoastronomy, have you got any recommendations of next steps that they could take if they were interested in some of the more historical and cultural aspects of studying astronomy?
Oh yeah, I would definitely recommend that they pay a lot of attention to the origins of this, right? The way our ancestors interpreted the skies gave way to what now we can scientifically approve or not, but those are the origins. And believe it or not, you will find it as incredibly amazing when you see that, for example, the pyramids were built in a certain orientation,
Yeah.
or Stonehenge, for example, was built there to predict the passing of the sun between two of these columns, etc. That is as amazing as being able to see far beyond or far into the cosmos with the modern telescopes.
I agree. I agree.
It's absolutely fascinating. So read a lot, travel a lot. If you're near any one of these sites, go there, try to imagine what these people may have thought about either of these phenomena, and help in the process of translation, because it doesn't matter how much we study the hieroglyphics, there is still a lot to discover. You get interested in that, and of course, you're going to go into a rabbit hole. It's a fascinating world. It happened to me, I can tell you.
Yeah, and I think the older some of us get, the more rabbit holes we deliberately jump down, because our thirst for knowledge just carries on increasing. I need to get some new bookshelves, certainly in my study here. Thank you very much, Milton, for that. I was just looking at this live stream coming in from our partner skylive.tv in the Canary Islands. It's actually run, that organization is run by some of the people, some of the professors actually, and some of the other staff at the Institute of Astrophysics of the Canary Islands, which is home to Slooh's flagship observatory, where we've got several telescopes. We've got a solar telescope as well, which is online during the day, during the week, which has been giving us some absolutely heart-stopping views of the sun, live views of the sun with huge prominences and flares and all sorts of things. I don't know if anybody read the news today, but one of the largest ejections from the sun, one of the largest flares, I think it was the largest flare recorded this year, was emitted, I think it was earlier today, knocked out, I believe, shortwave radio in North America for a period of time. So anyway, we get to see the sun live, but we also get to point the telescopes, the robotic telescopes, to all sorts of objects in the sky. And that's why I was just getting onto that subject, because looking at this, we know that the constellation of Orion is there, and it's not actually that easy to see. Now, most of us, where we live in our towns and cities, it's pretty easy to see the constellation of Orion, because the only stars that you can see in the constellation of Orion are the main stars. You can see the belt, the 3 in the belt, you can see the 4 in each corner, the feet and the shoulder and hands and stuff, but you don't see anything else. So it's really easy to recognize. But looking at this live image stream, I can remember the first time I went to Slooh's observatory many, many years ago, and I couldn't orientate myself at all. I couldn't spot a single constellation. Why? Because there were so many stars in the sky. I had never seen such dark skies, and that's kind of what this live stream is showing. There are so many stars in this live stream around the constellation of Orion that it almost camouflages it. It's almost like we can't see the wood for the trees. We can't see the constellation for the stars, and that's what it's like. And that first night I was there, you'll be able to see this if you have got dark skies tonight with no light pollution, you'll be able to see this yourself. But I was sitting there working that my first night there, and I looked up and I thought, oh no, it's cloudy. I'll have to pack up, stop my work for tonight. No, it wasn't cloudy. It was because the skies are so pristine there that the Milky Way was so bright. It kind of felt like it was illuminating the sky, and it just looked like clouds. I'll tell you, living in the UK and being an astronomer, I see quite a few of those. So anyway, those are the skies that you can point, students out there can point the Slooh telescopes to. Some remarkable objects. So I'm coming back over to Keith at the moment. Keith, I'm going to shoot you an off-the-cuff question here. What is the favorite object that you've captured using Slooh's telescopes?
Okay, well, that's tough. There have been so many. How do you pick one?
Pick your favorite child. That's what it's like, you see.
The shape, I would say, definitely one of them. Some of the shadow transits of Jupiter's moons upon the face of the planet, those are always exciting, especially when you can trace them over a couple hours and animate them. Those are a lot of fun. I really, really enjoy those. I enjoy getting glimpses of Mercury on Slooh because it's so rare and so elusive. It's one of my favorite planets. And of course, with the Slooh telescopes, those are usually missions that you cannot join. So I like to see it in the early morning because it's kind of a reward for either getting up or staying up all night, which is how Mercury is in real life. I like the early Mercury because why bother waking up at 5 in the morning before dawn? You just stay up all night, and that's the reward of seeing it at the end of the night.
Okay.
And of course,
So
it's
the
all the
rings.
beautiful nebulosity that we get a chance to look at, the beautiful open clusters, old favorites like the Pleiades and the Beehive, wonderful. When we had the Great Conjunction, the images that we saw through that were mind-blowing. I hadn't looked at those in a while. And going back and seeing Jupiter and its moons and Saturn and its rings in the same field of view is just, again, wild to see that. Not a mission that I ran, but one of our Slooh members captured Mars and something else. I think Mars and Saturn with a close conjunction. That was an incredible
One of
shot.
those. And we saw the moon occult Saturn and Mars over the years. I think the Mars occultation. So this is when the moon basically moves across the face of Mars and Mars just disappears behind. And we had some terrific close-up views of that from, I think, the Chile Observatory back then. Milton, over to you. What's the favorite celestial object you captured with Slooh's telescopes?
I think I'm more of a globular cluster kind of guy.
Okay.
The beauty of each globular cluster is fascinating to me.
So
and also
a
the
globular
planets.
cluster, tell us what a globular cluster is first of all, because some people watching may not know what they are.
Oh, sure. These are incredible groups of stars that are joined around one center of gravity, I would say. So they look like I don't know, a huge disco sphere, I would say.
It's a huge disco ball, isn't it?
Yeah,
So
absolutely. But the colors and the shapes that they have, and the stars. I can just imagine going through one of those in a spaceship, and marveling at all those stars in that cluster. So that's what takes my attention. And also, I love to watch the planets also, no, and their paths around the sky.
Yeah, because the planets to me just are this lovely nightly. Oh, look at that one! That was perfectly timed.
That was
Thank
nice.
you very much, Gretchen, for bringing the feedback up. That was coming in from the top left. That one, that was very typical of a Geminid. It was moving very slowly. It wasn't a huge fireball, but you could certainly see some structure on it as it vaporized. And we will talk about that. We'll take some questions as well if anybody's got those, and add them in chat. So yes, I totally agree with you. I do like some of the transitory objects. And there's another one whizzing across. That one went straight into the heart of Orion, I think. Poor chap up there. So some of the comets that we've seen over the years, some of those have been absolutely spectacular, and we are kind of overdue a really, really decent comet. But I love watching Jupiter. Just like you, Keith, it's like a mini solar system, and it's in its own right. Just over the course of 10 minutes, you can see the moons moving, the string of pearls, which is what Galileo Galilei described them as, stretching out from either side of the planet. Here we still got live feed, so we're still doing quite well. We had a little bit of a little bit of a space there when we didn't see many meteors, but that last one made up for it. So let's keep an eye on the live feeds. Right, I don't know if anybody has got any questions for us at all in chat. Otherwise, we can talk about. Actually, there was one thing, Keith, that you mentioned right at the very beginning, because it was when I was first learning about meteor showers. One of the things that surprised me most, and that is the size of the meteoroids. The vast majority of the meteoroids, so this is the particle from the comet or asteroid that's traveling through space before it enters the atmosphere. When it enters the atmosphere, it starts burning up and vapor. There's a lovely slow one that going through. It's called a meteor, which is what we've just seen there. But the speck, the particle that caused that, if we go back to that one that came in from the top left, the really nice one coming in. So in fact, actually, one of those wasn't a Geminid, was it? Because I think the one coming in from the top left was, but that one was coming in from a totally different direction. So that was just a sporadic meteor, one of the normal meteors that you might be lucky enough to see on any night. But if we go back to that Geminid, the thing that surprised me most about that was when I learned that the vast majority of meteoroids are the size of a grain of sand. But it's the velocity that they're entering the atmosphere with all of that energy. That's what makes them so spectacular. Keith, have we got any idea? I've never seen any study or data on the kind of mix of sizes. I know we often say, you know, grain of sand up to the size of a pebble, but I think there are very few that would be, you know, some of the fireballs we see are really the size of a pebble kind of thing, but, you know, probably a small pebble at that. Have you seen any studies on that?
Not studies, but you're right. I mean, grains of sand that burn up, they're not very big. But you know, there are studies that show that pretty much on every roof we have what are referred to as micro meteorites, where we have these very small objects that survive larger. You know, you have to imagine a larger piece of a meteoroid coming in, becoming a meteor, and surviving. And they've done, you know, sample testing and all kinds of things where you just sweep off your roof or your gutters, and it's covered in these micro meteoroids, very, very small things that have survived. How big they were when they were floating out in space is anybody's guess.
Yeah.
But I've seen objects the size of soda cans that have survived, that have come up for sale. There was one that came up for sale actually not that long ago. I don't think we want to switch to live feed, but I did send Gretchen an image of it. I mean, most of them are small, but we do have many examples. There are meteor hunters, people who will go out and look for the debris field in these impact craters here on Earth and dig up all kinds of things, usually using metal detectors. A lot of the meteorites do have some type of iron in them, and you can pick these things up with equipment.
Was that one? Was that? I'm not sure about that one. That was an odd one that just whizzed across the sky there.
Mostly small, but the ones that hit the Earth, yeah, I mean, they could be from, again, like a small grain to, you know, something the size of your fist.
But as you say, Keith, you know, if there's one the size of your thumbnail, a meteorite that somebody finds on the ground, we don't know how big it was when it was in space. It could have broken up as it entered the atmosphere, and then of course those smaller chunks, let's say it's a football size, you know, most of that material is going to burn off and vaporize as it goes through the atmosphere at these extraordinary speeds, and what hits the ground is just a tiny fragment probably of the original object. But you know, if it's frankly, you know, we'll have to look this up actually for our next meteor show. Let's take a look to see what size an object has to be, and some of this is going to depend on whether or not it's a rocky meteoroid or an irony meteoroid. How big an object has to be in order for it to survive, or any part of it to survive through the atmosphere. But we have seen examples of this. So there's a group of members at Slooh who have been tracking and monitoring near-Earth asteroids since 2008. And they started doing it because an extraordinary thing happened, an extraordinary event happened for Slooh members in 2008. We had warning that an asteroid had been discovered and that it was only 4 hours away from impacting the skies over Sudan. The object was called 2008 TC3, and Slooh members, because they were able to control the telescopes in the Canary Islands, were among a very small group of people in the world who managed to capture images of that asteroid hours before it impacted over the skies in Sudan. And it broke up, and in fact they did retrieve a great deal of material from that. Then of course we had the Russian event. What year was that? Can anybody remember the year of that, Keith?
Yeah, are you talking about was it Chelyabinsk?
Yeah,
Chelyabinsk. Yeah, that was a couple years ago. So I want to say 17, but that might be wrong.
Yeah, it could be. But of course, what we saw there, that was the most damage which had ever been done by any recorded meteor, a meteoroid.
Are you talking about 100 years ago? I'm sorry.
No, I'm talking about the Rashomon. Sorry, not yeah, I'm talking about Chelyabinsk. Yes, that's correct. And the damage was done by the sonic boom, because people saw this thing when it was being a meteor, and this was actually a fireball in its true sense. It was captured by so many dash cams, if you remember, but also people saw it. And what people did was they all went to their windows, but there was a sonic boom created by the explosion of that giant lump of rock and metal as it exploded, that it blew a lot of the windows in. So there are a large number of glass injuries caused by that. But Keith, did you mention Chicxulub then, or Milton? Did you mention Chicxulub, which was, that was a major event that was happening down in your
that
part
was
of
the
the
end
world?
for a lot of species. Chicxulub is a Mayan word that is translated to the devil's sting. All right, so it's one of the killers. And that's what the Maya were warning with each of these, showers. That one day they said the big one will show up, and that's exactly what happened back then. The size of that object must have been at least 100 meters, right? And so it hit the ground, and the consequences were devastating. So events like this, meteor showers and everything, should encourage all of us to keep looking up and keep looking at the sky, because
Exactly.
we're kind of overdue, for one of these big ones.
No, don't say that. So Keith mentioned something, early on, and it's something I always think about when we watch a meteor shower. So we are passing through Earth tonight, and last night is passing through a stream of debris left behind as asteroid 3200 Phaethon traveled around the sun. In other words, Earth is in exactly the same place that Phaethon has been. Our orbits intersect, thankfully not at the same time, which is what happened to the poor old dinosaurs back then. But it just goes to show, how many meteor showers do we see every year? And each one of these is Earth passing through exactly the same bit of space as a comet or asteroid has done. And of course, we do see impacts as well. I think it was a good number of years ago. The very first, it was on New Year's Day. I can't remember which year, but the very first asteroid that was discovered, it was discovered not visually in the sky by the sky surveys, but because the impact of it in the Atlantic Ocean, over the Atlantic Ocean, was recorded. And that was the first discovery like that. And there've been quite a few. So anyway, so we're still watching the live feed from the observatory in Tenerife, where I've just come back from. Been doing some work over there. We've got a couple of questions here. I'll throw this one over to you, Keith. Hank is asking, did Phaethon hit something, and the debris, or is it internal ice? So I think he's asking, did it hit something and that's causing the debris, or is it internal ice heating up by the sun as it passes close? Do we know that? I'm not sure.
Yeah, the current belief is that it is something internal. Now, Phaethon does, like I said, behave like a comet. So it does show a little bit of a coma, and it does show a very, very small tail. But the debris that they've calculated in the tail cannot account for what it is that we see to make up a meteor shower. So they've decided, the conclusion is that it is not something that we expect from a comet. It's got to be something internal to the core of the object itself. Current belief is that it's some form of gas that, as it approaches the sun, starts to evaporate and causes the outer shell to flake, and that casts off as debris, as material. The example that's often used is a dried riverbed. You can imagine the river once had water. As that water starts to dry up, you have this flaky, crusty appearance, and that's what they think is happening to the outer shell of Phaethon. And that gets expelled, and then it loops around, and it does it again in another, 17 or 18 months. And as long as those conditions exist, it will continue to do that and will continue to get better and better until that gas or whatever it is that's causing the outer material to be cast off has exhausted itself. Until when that's happened, and then it's anybody's guess. It may just kind of peter out, but it's expected to go on for many, many years, 1,000 years at least.
Certainly, we're going to be enjoying the Geminids, I think, for our lifetime. And I think most students who are watching, they're probably going to be enjoying really good Geminid meteor showers, even when they're little kind of bots in an AI machine or something like that. So if I had the opportunity tomorrow, I would transfer all of my thoughts into a machine. That's another discussion about the evolution of human beings in the future into our technological selves. But the other thing that always fascinates me, and this is where I guess it is kind of thinking about the science, but it's not kind of raw science. It's not the math of all of this, but it's about what we're really seeing. And when we see one of these meteors tonight, and if you're out watching tonight, hopefully if you've got clear skies, do try and get out there for an hour or two, wrap up warm, and see if you can see any of these meteors. And when you do, think of that little speck that's vaporizing in our atmosphere. That little speck is the leftover. It's kind of like the builder's construction rubble of the formation of our solar system from 4.5 billion years ago. It never made it. That little speck never made it into being a moon or a planet. It only managed to get a small rock or maybe a comet or something like that, and that's suddenly it's released from its parent body after 4.5 billion years, and just happens to find itself vaporizing in the atmosphere of the only known planet with beings on it that can actually witness its demise. I love thinking about that kind of stuff as well. Milton, I know you often think in those same kind of terms, don't you?
Absolutely. Putting yourself in positions like that is a very good exercise for the mind. And just imagine, somebody said very wisely that human beings are the universe marveling about itself, which means that the universe created us, and we are the ones realizing all these wonderful things. So I believe so. We are the universe actually marveling about itself.
We're the only ones who can comprehend it, that we know of. And of course we know that most of the stars, or the vast majority of the stars in our live stream here, have their own planets. We used to think that even solar systems were incredibly rare, but now, as the surveys get better and our detection methods get better and better and more precise and more accurate, we're actually getting to see that most stars have a retinue of planets, some very different to our own, but some like our own. We've even spotted some planets, not that we see them directly, we can kind of infer them from the observations, but we know that there are planets out there with liquid water, just like us, in the Goldilocks zone. So who knows? Life could exist. There's probably, though, Milton, life that we can't even comprehend out there as well. I know silicon life forms and all sorts of other life forms are mentioned in science fiction, but personally, I don't think there's anything that science fiction writers that can come up with, which frankly might actually be out there. What do you reckon?
I agree with you. And now that we're talking about objects coming from outside the solar system, maybe let me just introduce you to what you see in my background.
Oh, yes.
This is not my kitchen's tablecloth. It's the fine net that they use to capture samples like this of meteor called IM1, or interstellar meteorite 1. It's the first one that we detected, and this result of a spherical part is basically the result of the kind of elements that it had, more solid than even iron meteorites that we have collected, and an inordinate amount of beryllium, lanthanum, and uranium, according to the first studies. So this one is a real sample of something that came from outside the solar system in a hyperbolic
Wow.
orbit.
Space might look empty, but it's certainly not. Keith, over to you to finish up. Bring it back to the Geminid meteor shower tonight. Give your last tips for any students or members who want to go outside and see a meteor for themselves.
If you want to see this live, no equipment needed. In fact, it's a hindrance.
Yeah.
Naked eyes. Nature provided you with the most perfect set of equipment you need to watch a meteor shower by virtue of peripheral vision, night adaptation. Let those cones and rods work out so that they can detect faint points of light, and just go out and, as Paul said, just soak it all in and enjoy it. Doesn't have to be tonight if you've got cloudy skies. You can also go out tomorrow night and the night after that. You've got plenty of opportunity to go out and enjoy the Geminids. After this, the Ursids are coming up too. So we're going to pass through another cloud of dust. And that's easy to find. If you know where the Big Dipper and the Plow is, just look in that general direction. You're ready to go.
And Keith, you often talk about this on the weekly star parties. There's some other cool stuff that anybody going out to see the Geminids, certainly after darkness, they're going to see some other cool stuff as well. They're going to see two particularly bright objects, aren't they, in the sky?
Oh, Venus has been stunning the last few nights. This is, of course, early morning if you're out, but about 4 or 5 in the morning. Very, very, very bright. Venus is not in its full phase right now. It's actually in a gibbous phase, but it has passed in front of the sun, so it's still fairly close to us. Very, very bright. Gorgeous, beautiful to see. And of course, Jupiter is very well placed. The sun goes down. You don't have to stay up all night to see something. The minute the sun goes down, go out and you will see Jupiter, the brightest, second brightest object, I guess, in the sky.
And Saturn's visible as well. Saturn's looking pretty bright as darkness falls as well. I think nearly overhead, maybe, with Jupiter kind of further over in the east. But of course, we can also see the constellation of Orion as well, so that will help orientate anybody. And as we've seen tonight, we've been seeing quite a few of our meteors whizzing through the constellation of Orion. So if you don't know where else to look, and you haven't got a chair to lay back on, a garden chair to lay back on, then just,
if nothing else, Paul, this is the time that if you don't know your constellations, go out, visit us on Tuesday, learn about the winter hexagon. You will learn 6 or 7 constellations in an evening, and you are ready to go. Wintertime is perfect to view constellations because we have nice, clear, crisp nights most of the time, and they're easy to spot with Orion as our focal point.
That's great. Great tip there. So thank you very much, Milton and Keith. Thank you very much for all members and students who have been in the webinar chatting. I'm sure we'll talk about this more during the week and in the class and workspaces and stuff like that. Thank you everybody for joining us. We've seen some pretty cool meteors, and as technology improves, we actually land up seeing more and more meteors as the cameras get more and more sensitive. But this has been probably the best meteor shower of the year, mainly because so many of the other meteor showers have been wiped out by those full moons that Keith was talking about, that totally wipe out all but the brightest of meteors. But I think we've seen a good clutch of meteors, a good little collection today, so let's be thankful for that. Thank you very much for joining us. Don't forget, if you're not a member of Slooh, if you're a teacher out there and you want to bring live astronomy into your classrooms, hop over to slooh.com and check out our offering, curriculum aligned activities. We call them quests, some of which Milton has written, and those are the culture quests, but we've got a whole stack more as well. So anyway, listen, thank you very much for joining us. We've got lots to look forward to in 2024, because I don't think we're going to see you again on another public star party until 2024, but we have got so much to look forward to here at Slooh. Thank you everybody for joining us, and carry on enjoying the views wherever you are. Good night, everyone.
Good night, Paul. Thank you for having me.